So this is part 2 of the review for Chapter 1's quiz. And this is the second page of the review. So we're going to continue on describing all the types of transformation. And this is a level 2 type of problem. And I have this here so that you guys can have like a definition sheet for all the different types of transformation. So let's begin with this type of transformation where you have a function and outside of it there is a positive or plus a number. So if you notice, like, you have a function with parentheses such as you have this case here and you have like a plus a number outside, let's say plus 7, then what's happening here is it's shifting up. And so it's the opposite when there's a minus sign. This is going to shift down. Now, when you have something in parentheses or something under a root or absolute value sign, and the inside of the parentheses has a minus sign, that means it is going to be a right-hand shift. So shift right. Whenever there is a positive sign inside the parentheses or root, such like this, this is going to cause it to shift left. So positive signs on the inside shift left. And then there are other ones such that when you have a negative sign in front of your function, this is going to cause it to reflect over the x-axis. And then if you have a negative sign inside the parentheses where it's next to the variable, the independent variable, this is going to cause it to reflect over the y-axis. And whenever you have a coefficient or some constant in front of your function, if the coefficient is greater than 1, so like if you were comparing x squared versus a coefficient that's larger than 1 is like 3, like 3x cubed versus x squared, this is going to have a skinnier parabola or a more narrow parabola. So any coefficient that is greater than 1 causes the overall function to become more steep or more narrow. And if your coefficient happened to be a number between 0 and 1, so usually like a fraction or a decimal, this causes it to have a more wider, so more wide type of curve. And that's all the different types of transformations you can have. And so the third level here is going to be looking at, can you interpret a graph or a function and be able to tell where it's increasing and decreasing in interval form, and also find relative mins and max. So let's start by maybe recognizing the relative mins and max, because I find that that's a little bit easier to do. So when it comes to max, I notice I have one here and here for these two graphs, right? Because in this case, relative max are talking about in that location there is a maximum, and it's going to look like the top of a hill or the peak of a hill. So I have this one, and when you write max or mins, you have to write the coordinate points. So this is at -4, 3, and the other one's at 4, 4, looks like. And so I have maxes in those locations. And for the relative min, I have one down here because it looks kind of like a dip in a trough. So in this case, this dip here is at 0, -2. So I have a minimum at 0, -2. Now, for increasing intervals, now that we have our max and mins located, you can tell that the increasing interval starts here. Like this piece here is increasing. I'm going to put a plus sign. And then notice that this piece here is also increasing, while this piece between them is decreasing. So let me grab a different color here, maybe, what's a color I haven't used? So blue, maybe. Oh, maybe not blue since the curve is blue, maybe green. So this curve right here is curving downwards. So that is going to be negative. And then this part's also curving downwards. So that's going to be decreasing as well. So we have 2 increasing intervals and 2 decreasing intervals. Now for this piece here, notice that this has an arrow. So it's going to be shooting that way forever and ever. So this is actually going from negative infinity to about -4 is where it stops increasing. So I'm going to say from negative infinity to -4. I'm just using parentheses here for intervals. And then for this piece here, it goes from 0 to x equals 4. So 0 to x equals +4, and that's it for the increasing. For the decreasing, it goes from -4 to about x equals 0. So -4 to x equals 0. And then the other decreasing interval goes from 4 and then onwards to positive infinity, it looks like. And that is it for this graph here. Now, what if you're not given the graph, but instead you're given an equation? So what you can do here is graph the equation, and you can use a calculator for this. But in my case here, I am just going to do this part by hand because it is just saying that this is a right-hand shift. And that's not too hard to do. A right-hand shift, shifting it to +1 would be right here. So it would plot the vertex here. And because I know that this is a quadratic because of the 2, so I'm going to be drawing a parabola. And if I'm drawing a parabola, it's going to be swinging up like this. Now, parabolas are pretty simple because they typically either have an absolute max or min. So there's basically this right here is going to be the lowest point of the graph. So we actually have a absolute min, not just a relative min. So I'm going to cross that out and just say that this is also an absolute min. It just means that that's the lowest point on the curve, whereas relative means that it doesn't have to be the lowest, it's just the lowest in that location. So we have a relative min at, essentially this would be 1, 0. And there are no relative max because notice there's no hill-like peaks like these. Like these would be maxes, but I don't have any peaks here, so this is going to be none. As for increasing and decreasing intervals, you can see that this side here is decreasing, whereas this interval here is increasing. So for the decreasing, it's going from this arrow shooting up, so that's pointing towards the left, so it's going from negative infinity to 1. So negative infinity to 1. Where, oh, sorry, I read that in the wrong area. Should be in the decreasing area. Whereas the other side is going from 1 to positive infinity since it's shooting up with an arrow towards the right. So I'm going from 1 to positive infinity. And that's it. So that one's a relatively simpler interval. So for level 4 here, our last concept that we need to touch base on, this concept is looking at even, odds, or figuring out if the function is even, odd, or neither. So first let's go over the definition. I like to have the definition on the review so that way you can kind of refresh back and look at your notes. So for even function, they have a symmetry. and it's with respect to the y-axis. And what we use is the function notation where we plug in a negative x and see if it's equivalent to the positive f of x. Whereas the odd function has a symmetry, but it's a little bit different. It is with respect to the origin. And you can also use the function notation test. The only difference is it doesn't come out the same. It comes out as the negated version or the negative version of the positive. And so let's use these two examples to show how you can test if it's even, odd, or neither. So in this case here, notice that I've given you the positive function. We're going to figure out what is the negative function. So if I were to plug in negative x, I have to plug each one of these a negative x, so that would be negative x cubed minus 2 negative x. Now when we cube something and there's a negative inside, it still forces it to be negative. So this is going to be a positive, or there's going to be basically 2 negatives, x to the third. And then that would be a positive 2x because that there is 2 negatives, so that will become a positive. So those two are negatives, and so that's going to be a positive x cubed plus 2x. I want you to take a look at both of these cases. So notice how these two are opposite signs of one another. Like the positive version is both terms are negative, whereas the negative version actually turns out to be positive. Since they're opposite signs of each other, this is actually a odd type. It's an odd function. Whereas this one here, let's take a look. So we're going to plug in a negative x into the equation. And so this is also an odd power. So this will come out as negative x to the fifth plus 4. And when I look at these two and compare, these two are the same. This is a positive 4 and this is a positive 4. But unfortunately, notice how this here has a negative and this one doesn't. It's a positive. So because they're not completely opposite signs, you can't say that they're odd. In this case, this has to be neither. So if not all of the signs are switched, then it's probably going to be neither. And that's it for this video, guys. I hope you found this helpful. If you have any questions, feel free to email me.